Welcome to Octorum, the literature review for the obscure scientist. My name is Isabelle Berthelot, your host, with Oliver Hutchens, my co-host. Stay tuned for more. Welcome back, everyone. We are fired up for episode 3. You don't know this, but episode 3 is actually a huge milestone for us. Our process is that we plan our episodes far in advance and we record ahead of time. And the intro episode to episode 3 has been sort of our pilot project, making sure that we are coherent as podcasters and we can, in fact, record more than 2 successful episodes. So, if everything goes well with episode 3, we're going to start publishing our episodes, we're going to start publishing our website, so this is a very exciting week for us. This is a passion project for us, so if you're enjoying it, please like the podcast on Spotify or YouTube, follow us on our social media, where we also post short clips of our podcast to engage you and help you find the next episode that you'll be interested in. And please tell your friends and family about Octorum. If you have family that's interested in science, not just elementary science, but really wants to get their hands dirty, please share this. If you have friends that might be in the world of medicine or academia or research, please share our podcast as a tool to strengthen their curiosity and creativity in the world. And if you're reading a Twitter or Reddit post about cool new podcasts to listen to in the car or in the lab, please drop our name. We are all about fostering a community. We don't just want it to be a listener and speaker relationship. We really want to have a community of people that can interact with each other, that can share work that they're doing, and encourage each other. So thank you so much. We hope that you share.
Yeah, I was thinking of last episode. What I like that you said was just, this is episode 3, right?
This is episode 3.
Yeah. I mean, I was just going to say, I think you said in episode 2, if you're still listening, thank you. It's like,
but it's
you're
true.
You're among the select listeners who are receptive to what we're saying. And to that I say thank you. And if you've made it to episode 3, we're on a whole new level of just enlightened beings. Thank you for being here. Maybe you're just doing the dishes. Maybe you're driving a horrible commute. Maybe, you're just rotting alone in a room and you're just distracting yourself with this. This is what we're here for.
I love it. Okay.
Oh, yeah, back to topic. Yeah. Wait, I remember the second thing. Sorry. Also, if there are any papers you would like us to review or anything that you think would be conducive to the Octorum project, please send them in. We might read them.
Yes. We'll definitely read them.
No, we will read them.
We might use them. You can either do that through our contact page on our website, octorum.com, or you can send it to media@octorum.com. That's our email, as well as any other commentary, fan letters, fan love letters, anything like that. All right, so we have a very interesting topic today, as we always do. We're talking about insulin. Specifically, we're exploring the secret life of insulin, as I like to say. This episode idea is inspired by a presentation that I gave to an undergraduate endocrinology class this year about insulin as a sensory molecule for humans, not just as a metabolic molecule. So, I will be upfront in telling you now that sometimes we're all over the place. We did have a plan of the papers that we were going to review, and then about 5 minutes before we jumped onto this podcast recording, I decided to change it. Just bear with us. Hopefully we'll make it coherent. So, one paper that we are referencing today is called Critical Nodes in Signaling Pathways: Insights into Insulin Action, written by Cullen Taniguchi, Bryce Emanuele, and C. Ronald Kahn, published in the review section of Molecular Cell Biology in 2006. This review article introduces new organizational tools to understand complex signaling pathways. They define critical nodes as a point in a signaling network that is essential for the biological function of a ligand-receptor interaction, but also allows for divergence of the signal to facilitate crosstalk between systems and or fine-tune the response to stimuli. And Oliver, I can introduce this if you want, but I do like for our listeners to have a good definition of some of the more technical words that we're talking about. Do you want to introduce, what is a ligand and a receptor?
All right, I'm really glad you bring this up. You know, I don't think I've read the technical definition of a ligand for about 4 years, so I feel like I am basically guaranteed to butcher it.
Do you want me to do it?
I think I do, yeah.
Okay.
I was
Okay,
like,
I'm happy to.
it's a protein.
I mean, a lot of the times it's a protein.
Yeah, it could either be a protein or like a fat molecule, right? Or either a protein or a lipid.
I believe that it can be a wide range of molecules. It doesn't just have to be a protein because, I mean, right now we're talking about hormones. Not all hormones are proteins. You know, everything in our body, it's either a protein or it's modified by a protein pretty much. And hormones, for example, like steroid hormones, are not proteins in themselves, but they go through a cycle of development by proteins. A receptor, as we all know, I mean, that's pretty self explanatory. It's basically a docking site for two molecules that are going to interact, and the receptor is the one that is on the receiving end. Now, a ligand is what binds to that receptor. So it's essentially what is being delivered to that docking site. We call that a ligand.
This is in the cell membrane, right?
Receptors can be in the cell membrane or they can be within the cell. So I was
Mm.
talking about protein hormones. The receptor would be on the cell membrane and they would be received outside of the cell. But steroid hormones can actually pass through the cell membrane and therefore the receptor is actually in the nucleus. And
Mm.
so that's why a lot of like testosterone, estrogen, these are all steroid hormones and they're received in the nucleus, and it also allows them to directly affect transcription. It can affect, like we were talking about epigenetic changes in our last episode, so it directly affects DNA expression, actually. So it can be both. Essentially, in this paper, critical nodes are like four-way stops in an intersection where it can either provide a continuation of the original path of whatever cellular pathway we're talking about, or it can provide an opportunity to turn and carry on your journey in another direction. And so that's sort of what we mean whenever we talk about crosstalk in the context of these cellular pathways. This could potentially continue on linearly within the pathway or interact with something that might be off target with what the original pathway was about. So, in this paper, these authors argue that the most difficult aspect of studying cell signaling pathways is the identification of these nodes that either continue or modify the signal as it progresses. We aren't going to reference this paper a ton, but the reason why I did want to go ahead and continue to include it is, for me, one of the most significant things about this paper. It uses insulin signaling as sort of a case study for talking about an example of these critical nodes. And they talk about the complexity. I mean, think about it. If they're talking about critical nodes at all, that means that the pathway is more than just linear. You're having a lot of different interactions with different pathways. And what I liked about this paper in the context of this podcast episode is it is emphasizing that insulin is a complex molecule. It has a wide range of interactions. And that was the main takeaway for me for this paper.
So like the whole idea of the signaling pathway is just how molecules external to the cell communicate with and cause things to happen within the the cell, correct? Like the ligand interacts with the receptor, whether that be on the membrane, inside, wherever it is, and that causes an effect to occur within the cell. So this is kind of like the basis for intracellular communication, right?
Yes, usually the result is an intracellular result for these pathways, but like I said, the receptor can be outside of the cell or in the nucleus. And so pathways are very dynamic in that sense. I did briefly touch on this in the last episode whenever I was talking about secondary messengers. Essentially, this is how cells communicate with each other that might deliver some sort of sensory information and allow for cells to understand what's going on and then produce some sort of action or product. So whether it's like one cell to another cell or one area of a cell going to a different area of the same cell.
So it's like the internet of cells.
Yes.
I get it now.
Okay, good.
Just because to me that is just the entry point to complexity. Because they say in the papers themselves, like, we started off with this linear model where it's just, basically just thing affects thing, and then it makes this one thing happen. And they started trying to build an understanding of all the communication that happens in and between cells based off of that linear flow. But then I'm just looking at the graph that they give for network with critical nodes. It is just impossible to keep track of. Like, the only thing I really have as a point of reference, besides just thinking of like an ecological food web where it's like this eats that and that eats that, and then this thing eats two things, and then these two things eat the same thing. Like, that's the closest thing I have to think about the complexity of it. Yeah, there's just like a whole range of complexity going on here that, I mean, I already knew and assumed that, life and the way cells work is complex. But looking at how insulin, this one little molecule, flows between the cell is kind of breaking me open a little bit.
Yes. Part of the reason why I decided to maybe use a different paper to introduce the point and the narrative that we want to talk about in this episode is because this paper is so technical. I know a lot about cell signaling, and it was still a lot of information to process at once. And especially with cell signaling pathways, it's hard to verbally talk about. I decided against it for this specific episode. I am still obviously going to cite it in the show notes, and if you're interested, I would love for people to read it. I just think for a verbal experience and an auditory experience, understanding this information might be a little bit difficult.
I think just the acknowledgement is important more than anything, because especially like the second you start talking even a little bit technical, I think that is just what makes it a lot more intimidating, creates that kind of like perception of complexity. I think it is incredibly important for us to just say, this is a lot, to show that you can look at a research paper and say, this is a lot, instead of creating this expectation of you either understand this or you don't,
Yeah. I mean, even if you're a researcher, there's some times where you get overwhelmed with what you're doing, and maybe it's a little bit too much for the goal of what you have. But like I said, the reason why I wanted to bring up this paper is because it emphasizes the complexity of cell signaling pathways, especially in endocrinology, which is the study of hormones, and metabolism, which has to do a lot with endocrinology, but just the understanding of nutrition, of energy movement throughout the body. The main point of this paper is basically organizing this information a little bit more and making sure that you can pinpoint, all right, what are the hubs of these pathways that are really the main junctions in which there's heavy crossover of significant pathways, the direction could change. And usually the way that this happens in a cell signaling pathway, whenever the direction of the pathway gets altered, it's because in that hub, the actual machinery that exists aren't just one protein. Usually like 8 different proteins grouped together, and those subunits might have a very unique function, and another subset might have a completely different function. And so that's why things get so complicated, because even though one signal is being received, it might split off into 3 different actions. And so that's sort of what they're talking about in this paper. The reason why this was important to me is the fact that they're even using insulin as an example to explain this shows how broad insulin's role is in the body. And I wanted to dedicate an entire episode to talk about this and to conceptualize this, because insulin is something that is very present in our day-to-day lives. You don't have to be a scientist to understand and to have heard the word insulin before. Even a medical understanding, even a scientific education, we don't usually get the full breadth of what insulin is. And so that's why I wanted to do this episode, to both interest normal people who don't have like formal science education and help them understand, okay, what is this molecule? What does it really do? And what does it really mean? But then also people who do have a formal education, reframing and reconceptualizing what role it plays in our lives and the existence of life.
I think another really good reframing there too is just kind of like that change from pathological to more proactive health of, people don't talk about insulin when things are good. People usually wait to talk about insulin until somebody's getting diabetes, and then you're like, all right, well, what does their insulin look like? Like, we don't really have the conversation outside of that. And again, I feel like that just goes into this wider mindset of like, we don't care about our health until we are sick. And I kind of like the idea of making this conversation about like, oh, if this molecule is so important, looking at, blood sugar moderation, sickness, maybe this is worth talking about in the context of what is it doing positively? What is it actively doing in our lives that we should be caring about now and not just waiting for it to be a problem?
Yeah, I completely agree. And Oliver, from your perspective of someone who isn't a biomedical scientist, could you just sort of, whenever I say the word insulin, what comes to mind for you? Do you have an understanding of what it does?
Oh, I mean, when you say insulin, I just think about my grandma with diabetes. When you say insulin, I just think about my dad saying like, "Mom, your insulin, come on, look at your monitor," and her just not caring and dipping her finger into a tub of whipped cream. I mean, just like there's also my technical understanding of I know it plays a role in like modulating blood sugar levels and that diabetes or certain types of diabetes happen when the body builds up an insulin resistance and other types occur when the body is producing insufficient, too much, too little insulin to begin with. But when I think about like life application, realist understanding of insulin, I think about my grandma's struggle with regulating that.
And that usually is the perspective and the experience that most people have thinking about insulin, pretty much always linked to diabetes. Insulin plays an essential role in glucose clearance. That's its main role. The body has a normal range of blood pressure, blood sugar, temperature, pretty much every different value that we can monitor within ourselves. The body likes it to be in a certain range, and it's always working to stay within that range. To make a very long story very short, when you eat, your body digests carbohydrates found in sugars and starches through a certain digestive enzyme that's mainly found in your saliva as well as your small intestine, breaking down these larger carbohydrates into smaller sugars like glucose. And from there, glucose is taken up from intestinal cells and it enters the bloodstream where it can be delivered to tissues to acquire ATP for energy. This introduction of glucose into the bloodstream during eating is essential to refuel the body's energy, but the normal range of blood sugar is still maintained. The way that it is maintained is by insulin. So, insulin allows for glucose clearance from the bloodstream by initiating glucose uptake from various cells in the body and glucose storage in the liver and muscles. It's stored in glycogen. Fat can hold glucose that's stored, but it's not like it directly translates to fat. That is a common misconception, but either way, this clearance of glucose from the bloodstream allows for blood sugar levels to stay within the normal range, and because there is storage, even whenever you're fasting, it can still stay within that range. And whenever it's not, that's whenever you start to get really hungry and weak. And as many of us know, insulin is related to diabetes. There are two forms of diabetes that are distinctly different, although the outcomes of both result in inability to regulate blood sugar and keep it within that normal range. So, diabetes type 1 is due to autoimmunity, in which the body's immune cells attack itself and destroy beta cells in the pancreas, which produce insulin. This means that whenever someone with type 1 diabetes eats food, their blood sugar rises, but it can't be cleared or taken up by cells to allow for energy. High blood sugar is extremely uncomfortable and it's dangerous for the body. The body tries to eliminate excess sugar through urine, so people who have type 1 diabetes frequently urinate. It does lead to extreme thirst as well. That's a common symptom for people who have untreated type 1 diabetes, and vomiting can occur for the same reason as well. Without glucose uptake to the cells, people with untreated type 1 diabetes become extremely tired and do not have any energy to expend. Behaviorally, constant high blood sugar can also lead to irritability and outbursts. So that's another symptom, especially within young children. There was a time where the diagnosis was more prominent in infants and children, but there are a good number of cases now where people are actually diagnosed with type 1 diabetes and seemingly randomly develop type 1 diabetes as an adult. And so part of the reason why I wanted to go over these symptoms too is obviously we're not a medical resource, we're not doctors, but these are extreme symptoms that are related to type 1 diabetes. I believe if you're experiencing an extreme symptom of any kind that's out of the ordinary, you should go see a doctor. But especially for type 1 diabetes, because it seems so random, people don't have any medical history that would indicate that they would develop type 1 diabetes. And then even as an adult, like I have family members that develop type 1 diabetes in their 20s or 30s. So if you're experiencing things like urinating all the time, extreme thirst, extreme exhaustion, extreme hunger, that's could be an indicator that you might need to talk to your doctor. For type 1 diabetes, the only treatment for this is supplementing insulin because you do not have cells in your pancreas that produce insulin. And most people wear a blood sugar monitor to constantly track their blood sugar and then release insulin accordingly. The other form of diabetes is type 2 diabetes. And unlike type 1, type 2 diabetics do produce insulin, but it tends to be insufficient. So the lack of sufficient insulin production occurs because during long-term exposure of high blood glucose levels, usually due to an overintake of sugar, the body begins responding to insulin differently and the cells decrease their response to it, leading to glucose not being taken up by cells. This results in a lack of energy as well as constant high blood sugar levels, which do have similar symptoms to type 1 diabetes, like the frequent urination, the excessive thirst, but this high blood sugar level over a long period of time can also cause vascular damage. High blood sugar also decreases the immune system as well, and so people become prone to infections over time. And I will say I did work in an infectious disease clinic, and one dangerous combo that usually shows up with people who have unmanaged type 2 diabetes with these infections and this vascular damage. A lot of people will get infections in their extremities, like their fingers and especially their toes, because you can't really see your toes. And with the vascular damage, you also stop being able to feel them as much. And so people get infections and then it gets out of hand because they don't even know that they have an infection because they can't feel the pain of it. So that's just an example that can also show up within type 2 diabetes. But here's where things get really interesting, and this is why I wanted to make this podcast episode. The receptor that is activated by insulin, so the insulin receptor, can also be activated by another molecule with a similar form, and that molecule is called insulin-like growth factor 1. I'm pretty sure there's insulin-like growth factor 1 and insulin-like growth factor 2, and they're very similar, but to my understanding, insulin-like growth factor 1 is the one that interacts more with insulin receptors. Now, if you have endocrinology education or some sort of developmental biology education, you have probably heard about insulin-like growth factor 1, which I will be referring to as IGF-1 as well. You might have heard about that before, but other than that, this molecule is not talked about a lot. It's not socially understood in the same way that insulin is in our society. Actually, whenever we learn about IGF-1 in school and insulin in school, insulin-like growth factor and insulin are taught at completely different sections. They're not really discussed in tandem at all, which is very interesting because they do have the ability to activate the other's receptor. So insulin can also activate IGF-1 receptor, and IGF-1 can activate insulin receptor. The way that I think about this is almost like a parent trap type situation where you have these two twin-like molecules that do very different things and have very different lives, but they can also dress up and trick the other receptor to try to extend whatever pathway is being activated. Oliver, do you have any thoughts or questions about that?
Yeah, I like the parent trap example, or like the way of thinking about it, but otherwise, I mean, again, I just had no idea that the insulin-like growth factor was such a thing. I mean, where do you think that comes from? Why they're taught so differently? Is it because insulin is already so culturally, societally understood that it can be treated as an entry-level concept that can immediately be plugged into diabetes research and understanding as a commonly treated disease, while the insulin-like growth factor is still just kind of even though it's as similar, we don't understand it in the same way. So we kind of shove it away for later as kind of like not primary knowledge.
Yeah, I think that there's two separate issues here. I will say the first issue, what you just discussed, was our education of IGF-1. And I think part of the reason why we don't learn about it as much is the fact that insulin is a common thing that must be discussed in our modern world, especially in America, because we do have a good number of people who struggle with diabetes and who are diagnosed with diabetes. And so it's something that people have to understand. Diet culture is huge as well, and that has to do with insulin. But alternatively, IGF-1 is a hormone that is mainly active during the fetal developmental phase, and then it's also secreted during puberty, like in a significant amount. But other than that, it's not really something that is highly active during our lives, and especially during our adult life, like almost not at all. The pathologies that exist around IGF-1 and IGF-2 are more rare. So things like acromegaly, certain growth disorders, right? Because insulin-like growth factor, I didn't say this before, its main role has to do with growth, especially skeletal growth. I believe that's insulin-like growth factor 1 is mainly skeletal. I'll have to check that. But it's really about bone length and height. So things that affect growth would be a very obvious and rare pathology. You know, if someone's either really large or someone has dwarfism or something like that, that would be an IGF pathology. And that's not seen as commonly as insulin pathologies. The other issue, and this is what shocks me, and whenever I did this presentation that I talked about at the beginning of this podcast episode, the reason why I did it is I felt like the conversation connecting insulin and IGF-1 and truly talking about the ways that they interact, because they do. I felt like that needed a spot in the classroom. That isn't something that is discussed that much. It's definitely mentioned that structurally they're similar. I mean, it's in the name of insulin-like growth factor. We know that they're structurally similar, but they do have a lot of interaction. I do think that it also represents, you know, a different side of insulin. One thing that I wanted to ask you during the last episode, right? We talked about life being a tool to develop the environment. And the episode before that, we talked about evolution. And I wanted to ask you sort of your take. It's a very general question. If biological structures are able to interact with each other, like we talked about a ligand and a receptor, if they bind, to me, that indicates some sort of evolutionary significance, because it does take energy to evolve to develop a certain form. And so if something does interact with one another, it's probably made to interact. What are your thoughts on that? Or like from an evolutionary point of view, what's your take?
So just kind of like if you were to compare different ligand receptor structures from like an evolutionary perspective in terms of efficiency, or just like seeing these interactions as a product of evolution.
I'll give you a bigger example that isn't cellular, because I know that that might be hard to understand from your perspective. Like in the first episode, we talked about senses. And we talked about how the senses that we have are the senses that we need for our existence. And that is intentional. That's what we need to survive in the place that we are for the amount of time that we're meant to be there. Humans cannot see ultraviolet light. Like that was something that I quoted from the paper from episode 1. But if humans could see ultraviolet light, then that would probably indicate that that is intentional and something that we are meant to do for some sort of reason. Does that make sense what I'm saying? Like if two things interact, can we assume from evolution, because evolving requires intentional energy?
Oh, I think where you're coming from now. Can we assume that this is because it is here, it has evolutionary importance?
Yes.
Yeah, oh, absolutely. I mean, the other possible explanation for why something could exist that's been evolutionarily inherited as part of the species is if it's a vestigial structure, which a vestigial structure is like something that is being produced anatomically in the individual as part of the species that like kind of has a neutral effect on survival, or the effect is so slightly negative that it's hard for evolution to modify it out of the genome. So think about something like the tailbone for humans, of just it might play some structure role, but as a whole, people are just kind of like, do we really need a tailbone? We don't have tails. But it's not like it's bad to have a tailbone. It's not getting in the way of anything. It might be slowly weaseled out instead of something as extreme as everyone with a tailbone dies. All these new mutant people who don't have tailbones survive. So you can absolutely look at the insulin pathway as this honed over time pathway for efficiently communicating energy levels throughout the whole body.
Okay.
Is that kind of what you're looking for?
Yeah, I think that
Yeah.
that is going along the direction of what I was looking for. I think whenever I was considering insulin and IGF-1, what I was thinking about was if insulin can activate the IGF-1 receptor and vice versa, then to me that should indicate that there's a reason. There's a biological reason why.
Oh, yeah. Oh, yeah, no. All right, so I can break it down from that way. Let's just like imagine scenarios in which the insulin IGF interconnected pathway is bad. If this is bad, and in some way the interconnections of these two pathways are harming insulin's ability to modulate energy levels within the body, you can imagine that all the people who have that experience would just have super low, like energy efficiency in the body, much lower survival. Maybe these people would need to eat more to perform the same metabolic functions, or maybe these people will just have chronically horrible blood sugar regulation for the rest of their lives. I think there might be some evolutionary biologists who say, I mean, we can't say for sure, maybe it's going away, but I think it is well within safe territory to say this is here because it is doing something crucial and beneficial to human well-being.
Yeah. And so, with that being said, insulin, the fact that it does interact with the receptors of IGF-1 and vice versa, it shows that there is another role that is more than just the headline of glucose clearance. And there are a lot of papers that explore this idea. One that I read in preparation for this podcast episode is titled Insulin and IGF-1 have both overlapping and distinct effects on CD4 positive T cell mitochondria, metabolism, and function. And CD4 positive T cells, that's just a type of immune cell. That's the type of immune cell that mainly activates CD8 positive T cells, which are the real warriors of the immune system. But it's basically just saying that insulin and IGF-1 have a role on the immune system. So that's like the headline there. I mean, that shows that insulin does have a function other than just glucose clearance. There are a lot of other instances of this. But before I get into that, I do want to share one quote. This paper that I just referenced is written by Caitlin Kernan and colleagues, published in the scientific report section of Nature Journal, which I will also cite in the show notes. Everything that we talk about, I'll cite. Here, they also explain that insulin receptor and IGF-1 receptor chains can heterodimerize to form a hybrid receptor through which both hormones can signal. That's crazy. Essentially, that's saying like receptors sometimes requires two different, in this place, they call them chains. It's hard to visualize if you're not in cellular biology, but basically there's like two halves to a whole. And what it's saying is sometimes what these receptors do is they hybridize to create this half and half receptor that can now be activated by both insulin and IGF-1. Really going to show that insulin has many different effects. One paper that is actually the paper that I switched to last minute. The paper is titled The Insulin IGF System in Mammalian Sexual Development and Reproduction, written by Yasmin Nernyik and colleagues, published in 2019 in the International Journal of Molecular Sciences. This paper, I think, is really foundational in understanding the link between insulin signaling and its role on development and reproduction. The first sentence of the abstract reads, persistent research over the past few decades has clearly established that insulin-like family of growth factors, which is composed of insulin and insulin-like growth factors 1 and 2, plays essential roles in sexual development and reproduction of both males and females. Within the male and female reproductive organs, ligands of the family act in an autocrine-paracrine manner in order to guide different aspects of gonadogenesis, sex determination, sex-specific development, or reproductive performance. So That's essentially saying that the activation that comes with the binding of insulin or insulin-like growth factors affects development of our sexual organs in both males and females. The reason why this is so groundbreaking for me, and this is really the beginning of my concept shift of the way that I look at insulin, okay? The headline role of insulin is glucose clearance, but clearly it's having a lot of downstream effects on the immune system. It's having effects on our development. It's having effects on reproduction. And so to me, I wanted to think about insulin's role. Basically, what signal is insulin giving to the cells that are within the insulin pathway that aren't just glucose clearance? And to me, if you look at it in that fashion, it's indicative that because we're talking about survival, not just survival, but reproduction. In my mind, reproduction is the height of evolutionary security. Like, an organism will not reproduce if the environment doesn't have enough energy to sustain that organism. So, to me, one clear indicator of overall health is ability to reproduce. And in this way, because insulin is a major signaling molecule in reproduction, which we don't learn that classically in school, we don't. But it is coming to surface that, especially for females, a lot of female reproductive disorders, one of the cornerstones is insulin dysregulation. And to me, that indicates that insulin acts as a sensory molecule. It's like the cell's ability to take in sensory information of the environment. And because insulin is secreted whenever you eat, whenever blood glucose levels are up, to me, it's acting as a sensory molecule for resource security. What do you think about that, Oliver?
All right, I see the pathway that you're talking about now. So just kind of like it's all indicative of resource security, the quality of energy, food available in the outer world. Assume, like harvest is good, you got hella bread. You're just like, you eat bread, turns to sugar in the body, insulin modulates that, and allows for downstream of that sexual development saying, all right, we can reproduce, we have enough calories. And we're seeing insulin as like the universal messenger of that. And you look at these individual, seemingly unrelated functions, but then you look at them kind of like applied organismally or within the species context. This is all doing the same thing.
Right. It's actually the way that I thought about it, like whenever I realized this, it's kind of brilliant technology for the human body.
Mm-hmm.
Because if evolution is not going to allow us to keep regenerating our own cells and then produce another baby, like to be able to reproduce, that's not going to happen unless we're in an environment that can sustain us during that time. Well, what's a good way to evaluate whether an environment is stable? Well, can you eat? Right? Like that's the first thing that makes sense. And so how is the body going to, like, what tool are the cells going to use to indicate that you're eating? Well, it can't really be the blood glucose because the blood glucose is really important for the cells. Like that's actually the moneymaker. That's where the energy comes from. You don't want to waste any of that. So that makes sense. So then what's the next best thing that's going to always be there whenever we eat? Insulin. To me, it makes sense, right?
I mean, it's
It's
just like
actually beautiful technology if you think about it.
it's just such a big paradigm shift for me. I mean, just like thinking about, my weak little undergraduate biology baby understanding of just how cells communicate, my understanding of that simple linear signaling pathway model where it's just ligand, receptor, reaction. That's the beginning and end of it. I think I was always taught like, the kind of model key and lock, like you twist the key into the lock and then like it makes that one function happen, but you get one response. This is almost to me it's like you unlock the door to your house and at the same time like the lights go on upstairs. We're just like, whoa, like why the hell is that connected to what I just did? It's just, I mean, it's a pretty stupid example.
No,
But
but
just,
it makes sense
yeah,
because
just kind of, yeah, added,
anytime you're
yeah.
going to automate something, because there your example is talking about automation of an action.
Mm.
Okay, if you're going to automate something, if you're going to create a piece of technology that says, okay, if this happens, then activate this, then the most important thing is like, what's going to be your trigger? And so there, it would make sense that your lights come on because now you're home. And there's no reason for the lights to be on if you're not home. That's sort of what we're talking about with insulin. Like, it's the perfect trigger. And so
Okay,
it makes sense.
that is how I was trying to put it, but
It's kind of brilliant automated technology for the
mhm.
body. I also, after I realized this, it does make a lot of sense. Out of all of the other hormones, out of all of the other molecules in the body, the one that is closely linked to insulin is insulin-like growth factor, which it's triggered, like I said, during fetal development and then again a little bit during puberty, and then other than that, you're pretty much done. But of course, having it be something that regulates growth, like body height, body size, it would make sense that part of the sensory need that the body needs to activate growth is insulin, is feeding, is resource security. Not saying that insulin's going to trigger the IGF-1 receptors all the time, but it makes sense from an evolutionary standpoint, like out of all of the molecules that it could be close to, why growth factor would make sense. In the rest of this conversation, we're going to be talking about insulin signaling within normal human physiology. And so this is going to exclude type 1 diabetes. Type 1 diabetes is not normal human physiology. It's due to autoimmunity. Your body literally does not have functional cells that produce insulin. That is not normal physiology. But it can include type 2 diabetes in this context because type 2 diabetes, it isn't a completely abnormal physiology. It's basically a dysregulation of normal physiology. Type 2 diabetes is preventable. Insulin resistance that causes type 2 diabetes is preventable. And so there, it's still within the sphere of normal physiology. Does that make sense?
Oh yeah, that totally works. Because again, like what I wanted to throw in there at some point too is that we are already on this conceptual shift towards making it clear that there's so much more going on. So there's already like that nice little pathway of being like, oh, this is about more than just sickness.
Yeah. Like here, I want to talk about insulin in itself, what it does, what can happen. We can't even do that talking about type 1 diabetes because there is no insulin. That is not normal. But basically, talking about normal physiology, using all of the information that we just talked about, potentially changing our conception of insulin as now a signaling tool for the cells, a sensory tool for the cells about the environment, because your cells don't have eyes. Your cells can't see where you are and like understand if you're safe. It's really just based on, the triggers that we can receive that makes sense based on our environment, like what we were talking about, these automated triggers. Insulin's role in promoting growth, promoting reproduction, promoting healing, because like I said, insulin does have a role in the immune system. High blood glucose and low insulin are bad for the immune system, like we talked about in the comorbidities of type 2 diabetes. I want to reframe, and change our conversation to sort of transcend this to think about how are actions of people in the modern world influencing this intelligent biological sensory system of insulin. That's what I want to
Mm.
transition this conversation to. In the modern world, we are fully surrounded by processed foods that have an extremely high sugar content. High fructose corn syrup is extremely concentrated sugar. We have processed carbohydrates like found in modern flours and breads and pastries, and these are skewing insulin reflecting resource security because it's skewing the amount of energy that exists in the food as it relates to resource security. Like Oliver and I went to school in a very rural area. It is considered a food desert. It was also surrounded by a very impoverished area. And so instead of people having even grocery stores to go to, like you would have to drive 30 minutes to get to a grocery store. Instead, where people were getting the majority of their food was the dollar store. And a lot of the foods that exist in the dollar store are highly processed foods that now have very high sugar content, processed carbohydrates, to where whenever you eat it, your blood glucose level is going to skyrocket. And normally in nature, if your blood glucose level is skyrocketing, it's reflecting that your environment is rich in energy. But that's not the case for this food desert. It's just because this food is processed. And so I want to understand, like, what are your thoughts or feelings about how the modern world has skewed this intelligent technology that our bodies have in being able to sense our environment based on our nutrition, essentially.
Hmm. There's a lot of cool stuff there. I mean, the word that came to mind was abuse of the communication network. If you want to treat this as like our body's way of communicating with what's going on outside, it's like we have just accidentally created this whole way of flooding that whole system with information that does not make sense. So it's more of just kind of like,
It's like hijacking.
yeah, it's like mixed signals. I was thinking of the 24/7 news cycle or like the internet where people are just kind of like, man, I thought this thing just existed to, show us like photos of funny cats. Now it's just turning into whatever the hell it is now, and it's just stressing me out. That's how I
Literally,
was,
what
yeah,
it's
that's how I was
doing
thinking
is
about
like
it.
the over stimulation that you're
Mm-hmm.
getting. For example, you're talking about social media. What does that cause in people? Desensitization.
Mm.
Desensitization is literally the
That's the insulin
pathology of type
problem.
2 diabetes. You
Mm.
have insulin resistance, where you're constantly being bombarded with sugar and your body is being desensitized to insulin because it's producing so much all the time. Now it's like crying wolf. Insulin comes back around again and your body's like, all right, maybe something's going weird and we just have too much insulin and we're just going to ignore it for now. And that's how type 2 diabetes happens. But it's right. It's like it's hijacking. Your body is thinking, okay, we're in a very abundant environment because we're being bombarded with this energy, so we must be good. I also want to consider alternatively, like the behavioral roles that feeding plays in our lives, right? Like, if what I'm saying is true and food triggers insulin and therefore insulin has this effect on the body of resource security, then it does kind of make sense why, for a lot of people, eating is a coping mechanism.
Or like creating this false sense of stability or abundance. Whatever other signals you're getting in your life, you do have this one pathway where you can tell yourself, oh, everything's fine.
Yes, yeah.
That is a really cool way to read the issue. Because again, it's one of those things of just kind of like, it's one of those problems that people don't know that they have. To varying levels of self awareness, you can understand. But being able to say, like, what's actually happening while we have this own ignorance of what's going on in our own bodies. And again, linking that to an ignorance of overall what insulin is doing in our body. This does provide what could be like a really beautiful explanation of what we think is happening versus what's really happening, or kind of like why this behavior is functional.
Yes. And I would even say that, like, coping in that way isn't always a bad thing. I think obviously if you're not able to control it, if you're binge eating, like, obviously that's signs of an issue. But I do think that it can be used in a conscious way to, like, make the body feel more safe. It's also really interesting, like, think about the foods that we gravitate to whenever we are feeling like we need to cope with something that's going on.
Yeah, like
Whenever we
comfort foods.
Yeah, and
Yeah.
especially, I don't know about you, but like chocolate for me, stuff like that. I mean, not all foods trigger insulin in the same way. Even thinking about the comfort foods that often go along with coping, it does tend to be like high sugar content foods.
I mean, what I was thinking when you said that is nobody's eating celery to take the edge off, Like, it's not going to do much for you. I mean, maybe if you're a little dehydrated, you might be getting some electrolytes, but nobody's just taking a crunch out from cold, wet celery and saying, that's making me feel better?
Yeah. And I do think, like I talked about chocolate, I think that
Mm-hmm.
there's a way where it can be okay. Like, I think part of the biggest issue with processed foods and why it feeds into this so much, we do have a really interesting phenomenon happening in the modern world where we have obesity, the epidemic of obesity, also going hand in hand within the same people with the epidemic of malnutrition. And so to me that's another part of it. That's why processed foods are so dangerous, because if you're going to have high sugar content in something, then what should happen is there should also be a high nutritional content. And so with a lot of these processed foods, you're having high sugar but no nutrition, leading to obesity but malnutrition, because you do, like, essential vitamins, you need that to survive. Like, you need vitamins to survive, and you need to get it from your diet. And so I also want to be sure that in this conversation, we're not framing carbohydrates or sugars as bad. They're not bad. It's just, the way that makes the most sense within nature and what this technology of our bodies is meant for us to do is to be able to sense the environment. And I think that part of the reconciliation that can happen with this issue is having, say that we want sweets or say that we want something that is high in carbohydrates, then also having that thing equal in ratio with nutrients. So I was talking about chocolate. To me, whenever I'm feeling sad, whenever I feel like I want to have a little bit more like security and I want to cope with food or something, I'll eat dark chocolate or something. Because to me, is there sugar? Yes, but there's also a good amount of other vitamins, nutrients, minerals, things that are helping me as well. Does that make sense? Like, having sugar content also be a reflection of nutritional content.
Yeah. I mean, I just go out and say, I don't think we're going to solve the obesity crisis or any social issue. I mean, it'd be cool if we somehow inevitably did, just by announcing the fact of like somehow we figured it out. But I think just it really is just grounded in the understanding of just what other factors going on in your life. Again, just thinking about the complexity of life, there is this one little piece of it that is the insulin pathway of just understanding how this feeds into the larger context of your life, of like whatever else you're dealing with. I mean, I was thinking about my own relationship with food, of like there are times where just going through rough periods where I was eating a bit more extravagantly than I probably should have, where I'm just like, all right, you know what? Like, as I'm just tearing into a tiramisu, I'm like, you know what? This could be a problem. I'm having a great time right now. If I keep eating tiramisu, I'm probably going to end up in a worse place I'm currently at. But again, it is playing this role of just, even if there are other points of, I'll just use broad language of like stress or inflammation in my life that I either can't deal with right now or are working on until then, I'm going to eat a little bit of tiramisu just to take the edge off. So again,
Yeah.
just to use my beautiful healthy habits as a way to exemplify how, there's the complexity of life and how, like this isn't just a binary of you're either a healthy saint or destroying your body. There is this insulin pathway in your body. This is what happens when you eat this way. Do with that information what you will.
Exactly. Like you said, we're not going to be able to solve this issue, but I think, well, mainly I think it's an economic issue. Like, no matter
Mm-hmm.
what we do, we can't, like, fix the economy just by talking. But one thing that we can do is provide more education. It would make me feel better that no matter what decisions people decide to make, they're informed decisions. And I do think for a lot of these areas, like we were talking about, a food desert area that is impoverished, where the main access to food that people had was from dollar stores. I also think that in those areas, because of poverty, because of development that's really slow with infrastructure of the area, there likely isn't sufficient education around the topic of nutrition, sugar, food. And so to me, it makes me feel better to know that we're spreading more information. That's another reason why I'm very passionate about, in general, this podcast and specifically this episode, because like I said at the beginning, insulin dysregulation does a lot more than just cause diabetes. Like, it has effects on the immune system. It has effects on reproduction. I mean, I'm not even gonna lie to you. My specialty is gut immunology. Like, that's what I'm interested in. One topic of interest that has always been close in my mind, anytime I have an opportunity to do a project or something, I usually do it on PCOS, which is one of the most common female reproductive disorders. There are a lot of female reproductive disorders that I simply do not think are researched enough. And to me, understanding the link between insulin dysregulation, blood sugar, and reproductive disorders, like what this paper was referencing, is really important. I think that it needs to be more of a topic of conversation. I think that the overarching narrative of what if we looked at insulin as a sensory tool for the environment? What environment do you want to let your body know that you're in? Like, that's an important thing, making sure that what you're putting into your body is reflective of what your body should know about your life. I
Mm-hmm.
think that that's really important, and I don't think that it's the fault of people who have dysregulated diets. I simply think we need better education about it because people are doing the best that they can. And I think that if people understood more solutions that they can take on, they would do it. But we just don't know people don't know what solutions they need.
I mean, I thought there was something really incredible in there. Just that reframe of just if this is anything you're navigating in any capacity of your own relationship with food diet, changing this insulin pathway from this mindset of, damn, I'm eating how I'm eating, treating that as an unrelated fact. And then now I know my body's going kaput. Like, damn it, that's annoying. Changing it from that to saying, I have this communication network in my body that gives me the ability to communicate with myself. And you can ask yourself the question from a place of personal agency, and it's kind of like self-empowerment of saying, what do I want to tell myself?
Mm-hmm.
I think
Yeah.
that's an incredible thing to be able to show people.
Yeah, and I like to think that all of our episodes sort of have this theme of bridging environment and self. And so I do think that I like the fact that this fits in with that. And I also like the fact that this is the third episode. I think that it builds up on the previous two really well.
Mm-hmm.
But the last thing that I wanted to say about this paper that I referenced, the paper being the insulin IGF system in mammalian sexual development and reproduction. The paper is very interesting. It goes in detail about especially sex organ development as it relates to insulin signaling and IGF signaling. I don't feel the need to go into that much detail for this episode, but the one thing that I want to mention is the way that this paper ended. Quote, it says, the exact mechanism through which insulin IGF signaling functions in the male and female reproductive organs is still not fully understood. And so I think that it's just basically calling to action for science research, trying to invest more in this topic, which I think is essential. But with that, with the conversation that we're having, we just talked about eating as coping. We talked about eating as, basically giving sensory inputs about our environment. I want to go all the way on the other side of the spectrum, and I want to talk about the cultural role of fasting as purification.
No, I mean, I don't think that's a huge shift at all because that feeds in very beautifully of, again, I mean, I think it's the question I already posed in the context of if you do have this communication pathway in your body, what are you trying to tell yourself? And then I guess, the sub question you could put on that is, what are you telling your body by withholding? So, like, what message are you delivering and how's your body responding to that message?
And what do you think the message is?
How are we going to answer the question of what are we telling ourselves by withholding food? The article we have to try and answer that question is Mutant Spiritualities in a Secular Age, The Fasting Body and the Hunger for Pure Eminence by Joe Nash, which really just gets into this from a whole new angle, even if it's trying to answer that same question we just posed.
Yes, and one of the topics of discussion in this paper is the difference between fasting and eating disorder. And so that is something that is discussed, and that is like a sensitive, whenever we're talking about like blood sugar regulation, having a conscious diet, that is a sensitive thing that we need to navigate because what we're talking about is paving a way for a more conscious relationship with eating and environment. And that's one of the things that he explains very well, like in terms of the differences between eating disorder and fasting. Like eating disorder is almost a loss of control, a loss of conscious eating, to whereas fasting is supposed to be a regain of control. There is a quote around this that I do want to share, or I guess not a quote, but basically the words that he uses are for eating disorder, it's disorder. But for fasting, he describes it as a reordering of our eating and of our feeding patterns.
I mean, the way I've been thinking about it is, continuing the theme of bodily communication. I think of, if we want to continue with that language, fasting is almost kind of like having that conversation where, like, an eating disorder might be something more akin to telling the body what you want from it. Like, I'm imagining a more conversational versus a more one-way authoritarian communication model. Right, does that make sense?
Yeah. Do you want to go ahead and introduce sort of the physical significance of fasting and removing the self from the environment to think purely about the self?
So kind of like just the maybe like the purest sense of solitude. Yeah.
Develop it.
Yeah. Oh gosh, I mean, as you were
Oh,
talking,
golly.
oh, oh boy, oh gosh, oh golly, can I make it happen? I don't know if I can. I sure hope I can make the conceptual connections. Yeah, I don't know. I don't know if I can be as reverential to the paper as we wanted, but just to build on that thing I was just saying right now, like if we do want to extend that idea of this is communication, or broadly invoking just kind of like the spiritual understanding of just solitude and a meditation practice as a tool for clearing the mind, building a stronger sense of self, could we from that angle look at fasting as a way of just, cutting yourself off from the environment completely, invoking that insulin understanding as a model of communication between inner body and environment as a way to like an even higher level. So just seeing fasting as a way to choose solitude in the realest sense, about saying I'm not going to let anything from the environment even reach my inner body.
Last episode, we talked about life being almost this machine to develop the energy in the world around us. And it's like that was our role. We talked about reconciling that with the idea of the self. Like, who are we if we're just these machines? Because, I feel like I'm Isabelle and you feel like you're Oliver, but are we really that if we're just these machines? I almost feel like part of the interesting cultural thing about fasting and conceptual thing about fasting is you're almost removing yourself from being that biological role. You're really, it focuses on, like, you're not a machine anymore. You're not developing anything anymore. You're purely Isabelle, not a machine, just me. It gives you really room to meditate on the individual. And it, I think, in that way, removes not just the individual from the environment, but the individual from like this physical gridlocked world. And this paper, one phrase that he continues to use, and I think he's borrowing it from a previous work, but he talks about a body without organs. Like, that's one way that people have visualized the goal of fasting. It's almost this body without organs, which to me, it's almost like self without a body, you know? And he talks about this emptiness, this lightness, not having heaviness anymore. You even talked about whenever you feel the most embodied, it's like gravity. And so it's almost
Mm-hmm.
like removing embodiment at all, removing the physical experience of life at all, and truly thinking about the individual experience conceptually as a plane for meditation.
I mean, as you're saying all of that, the question that was coming up in my mind is who is making the decision to fast? Like if you do think of as energy input, the way that it does feed into organismal survival, reproduction, evolution, survival, looking at the flow of energy as a purpose of evolution, that logic would say that nothing should get in the way of the intake of energy of that interaction with the environment. If that is the case, it's not the organism making the decision to fast. It's not the species as our understanding of it. What part of us is saying, no, we're not eating right now, when everything else is telling us that's what we need to do? Like,
Right.
what is
That's
that pointing
what's
in the direction of?
That's what's so interesting to me because to me it's almost like the most human thing. Because us as humans, we have this constant struggle of being animals, but then feeling like we're so much different. Like feeling like we're our consciousness, not knowing where to put it, not knowing how to fit ourselves in with like the nature of the world because we don't feel natural. And I think that this is like the most human thing of trying to remove ourselves from this being a cog in the biological machine. And it's almost the last thing that we can do to try to take back our power of what an individual is. Whenever I was naming this episode, right? This episode, which I might change, but for now it's called Insulin and Existing. In that way, because humans are able to make this conscious choice to not eat, like to fast, to not participate in the ecosystem, to not participate in the environment, to not participate in the physical world. We therefore, because we know that insulin is connected to reproduction, we know that insulin is connected to the immune system, we're also removing ourselves from the community. Does that make sense? Right? Because reproduction, immunity, like all of these things have to do with the individual's role in a community. But without those things, then we're also removing ourselves from the community. It's almost like we're opting out of existence for a little bit
And it's just like
and
it's
trying to transcend existence.
it's like delivering that message into the body. Like it's not just walking away and saying like I'm gonna have 15-minute in my corner reading time for a little bit. It's like telling your body, no, we are not doing this right now.
Yes, that's the best way that I've ever heard it described. It truly is giving that message to the body. Earlier, we talked about being aware of what environment we're letting our body know that we're in. And we can think things, but our cells don't get the message. And basically, what this is saying, it's a meditation of the body in that way.
There is some like nuance there that I want to navigate a bit more though, because just returning to that idea that I think is really fascinating of what is that subtle difference between anorexia and fasting, or just kind of like if we want to think about this as what makes us go well and what makes us go badly. I think what we just said there, what makes that really amazing is it's telling your body that for the sake of being able to communicate that and for your body to reflect the need of that, of maybe coming from this place of there's whatever reason, whether it be I need to figure something out, I need to think about something, I need to further ground myself in my sense of being. And for that reason, we need to physically cut ourselves off right now. I think about that as almost like a mutual conversation. It is not just like, do this because I said so. It is like almost an argument you're making for your body.
One thing that I wanted to touch on, I mean, you basically were talking about indicating to the body that you're in a time of purification, like whether that be mentally, spiritually. I mean, our listeners don't even need us to say it. Fasting is a huge ritual in so many religions for this reason. Like it encourages purity. And I think that some people make the conscious decision to do it before, but a lot of the times, like what we're talking about is delivering the message to your body. But a lot of the way that I've heard people talk about it in a religious context, it's almost like if you're having trouble getting your mind in that meditative frame, then if you make your body do it first, then your mind will get there. Like that's one little distinction that I wanted to make. At least that's how I think a lot of people look at it from a religious perspective, and in that way it can be a tool to transform the mind. But I do also really like what we were talking about with letting the body follow you rather than you following the body. I will also say, I mean, at the beginning of this episode, we talked about if there is a biological phenomenon or a biological interaction happening, then because of the energy that it takes for organisms to evolve to be a certain type of way, then we should assume that it's intentional. I will say, the second paper that I quoted in this podcast episode was talking about how insulin interacts with the immune system. Whenever you have high blood sugar, blood glucose levels constantly, your immune system is severely depressed. Whenever you're in a fasting state and you do not have insulin activation, your immune system is activated. And so, in that way, it's almost like a biological reinforcement of purity because your immune system is being activated, even. Like it's even ridding yourself of illness.
Mm. So it's almost like telling your body, it's like, don't worry about taking stuff in from the outside right now. We're just kind of like reassessing, figuring out what we have going on in here. That is our focus right now. It's
Yeah.
like everything's devoted to just figuring out what's going on within the system.
Mm-hmm.
That's really cool. What I did want to touch upon again is like, again, the idea of the insulin pathway as like a way to have a conversation. I think that feeds into just what you were saying of just how fasting has been, is commonly understood as just the body makes it easier for the mind. This could be kind of like the other part of that conversation where it is the mind making it easier for the body by the mind saying, this is what we're doing. That's a little communication cycle right there. It's like the mind says to the body, we're doing this. The body says, all right, let's do this. I'll make it a little bit easier for you. You just keep doubling down and you get into like a little feedback loop where you do get into a mind body, both integrated state conducive towards whatever you're trying to do.
Right. And I think the point of purification in this sense, I think, is always to return to the community different. I do want to make a clarification that we're not advocating to like fast forever.
Yeah, the
Like
goal
there
of
is
fasting is not to starve to death.
right. The goal of fasting is to return to the community different, to return to the community purified. And I just, yeah, I think it's really beautiful the way that we've discussed the role and the connection of eating to insulin, to security, to intentionality, to purity. I think this has been such an interesting intellectual journey, and I definitely feel like I'm walking away from this conversation feeling like I understand more about the world and understand more about what I as a human can do to understand my world better.
Yeah, I mean, I absolutely agree. I think this is just such a beautiful example of what we're trying to do, of just how science can so deeply inform truth, of just, you just take like an academically expanded understanding of what insulin is. And just the second you do that, you realize this allows us to better understand what's going on with fasting. Science becomes physical, becomes spiritual.
Yeah.
You know, like that whole little transition, like, I hope we covered pretty beautifully. I mean, it's all there at least. There's a little Simone Weil quote that came to mind while we're doing this.
You should, I mean, if this is Simone, you should give a little introduction because I feel like we're going to be quoting her a lot.
This is Simone Weil's Gravity and Grace. It is a text that has been so deeply integrated into my life that I feel like there's something that happens every day where at least once a day there's a quote from this book that comes to mind. And both me and Isabelle, I think I'd say we're both pretty big Simone Weil fans at this point.
Yeah.
Yeah, she's one of those people that anytime you think you've discovered anything about life, she's already said it 80 times better than you ever will, so you say, why am I even trying? Solitude. Where does its value lie? For in solitude we are in the presence of mere matter, even the sky, the stars, the moon, trees and blossom, things of less value, perhaps, than a human spirit. Its value lies in the greater possibility of attention. If we could be attentive to the same degree in the presence of a human being, ... Which just feels like such a beautiful feedback into what we're just saying, of just like what does happen when we do bring ourselves into this state and then eventually go back to those around us.
Hmm. Thank you so much for listening to our third episode, which is the last episode of our pilot project, which means we will be getting back to you more regularly and confidently from now on. If you have any questions, comments, or would like to say hello, please either email us at media@octorum.com or find us on our website, www.octorum.com, on our contacts page. Thank you so much.